Okay, so my name's Andrew Allen. I'm one of the technology specialists here at NHP. You'll see from the slide on the screen there that Chris Mears is the second technology specialist. Chris takes care of the north and west of the country, and as you can see there, I take care of the southern regions as well as New Zealand. So the purpose of today is just to give you a good overview and an understanding of the Plant PX system, and also to give you a first-hand look at some of the tools and utilities we've got, which will greatly enhance the engineering effort required to put a system together. So the Plant PX is referred to as a modern DCS. So I guess the question that comes out of that is what makes a DCS modern? Traditionally, a DCS has been used for the core process control in a process environment, and they have done an exceptional job at performing that process control. But in today's environment, we find that more and more the operation is looking for a more holistic approach, a control system that can encompass not only the process control, but also the ancillaries around that, safety on the machines and the process, better access to data and information across the entire plant. And often in the past, integration of a traditional DCS with the other plant systems has been quite difficult. So a modern DCS gives us all of the key capabilities that we are used to in a DCS system, while also giving us those other features that are important today. Access to information, flexibility in architecture, design, delivery and support. And importantly, one of the key things that I want to make sure that you understand today is that it's a scalable solution. So typically with a DCS, we think of larger systems, process control intensive. One of the big advantages of the Plant PX system is that it is scalable from a very small system, what we often refer to as a skid-based system or a small CompactLogix controller, right through to a very large distributed thousands of I/O type system. So just what we're going to cover today, we'll have a look at exactly what is Plant PX. We'll have a look at how it goes together, so the engineering aspects of it. And then I will give you a first-hand look at the end result, so what a Plant PX system looks like, and also we'll have a look at some of the tools that you can use to put that system together. So in a nutshell, Plant PX is a pre-built control system. Most of the expensive and time-consuming engineering and design work has already been done, and it's simply a case of taking those pre-designed components and assembling in a way that meets the requirements of your control system. So what do we need? What makes up the Plant PX system? Well, it's based on the Logix controller platform, so whether that be CompactLogix or ControlLogix, and obviously along with that is the RSLogix 5000 programming environment. For the visualization aspect of it, we can use FactoryTalk View SE or ME, so that allows us to use panel view terminals or the SE PC-based distributed control systems. And part of the Plant PX pre-developed components, there are visual components for both the ME and the SE system. And an important part of it is the process library, the library of components, which I'll go into more detail, the add-on instructions and the objects that go on the HMI screens to let you represent your plant and to interact with the plant. Along with the library, there is an extensive documentation set. The documentation set includes information on virtualization, controller design, network design, the FactoryTalk View environment, and there's aspects in these manuals, there's key information, particularly around the virtualization area, that you'll find in these manuals that you won't find in any other Rockwell manuals. They're a really useful resource, for anyone that's involved in implementing a Rockwell solution. You'll see there that the process library, it's a free download from the Software Compatibility and Download Center from the Rockwell software site. So there's no additional cost in implementing a Plant PX system. It's the hardware, the software that you'd be using anyway, and then we're implementing the library to achieve the functionality that we require. So this is a look at the first look at the library for those of you who have not seen it before. So it consists of add-on instructions which are implemented in the controller, and that's what you can see there represented on the left-hand side of the screen there. And then there's a number of objects for the displays for the FactoryTalk viewer environment. The global object, and there's various forms of these depending on whether it's a motor, an analog value, PID loop. There's an object that represents that which goes on the display screen, and then from that global object we launch into a series of faceplates that allows us to see detailed information about that object and to interact with the object. One of the key features of Plant PX is that we're able to do a lot of the configuration, troubleshooting and maintenance actions from the screen. We don't need to be going and making use of the Logix 5000 environment all the time. We can do a large amount of that work directly from the HMI screen, and that's the functionality that's built into these faceplates here that I will show you as we go further through the presentation. So you might be asking what objects are available, and this is perhaps a little bit of an eye test, but this is a list of all of the objects that are currently available in the library. So when the library is downloaded from the Compatibility and Download Center, it's in a zip file format, and within that zip file there are various manuals, release notes, and there'll be add-on instructions and faceplates related to all of these objects here. So starting on the top left, you'll see that there's a group of objects referred to as I/O processing, and as you would expect, they relate to the raw I/O signals, so analogs, digitals. Then we get down into the more advanced control, PIDs, procedural control. So we have some basic procedural control as part of the library. So the library is centered around control modules and the objects, but we do have some procedural control. As you can see here, we have a simple sequencer. We have some dosing control for flow meters and for weigh scales. Then below that, you see that there's a range of objects for motors. So a range of DOL motors, single speed motors, two-speed motors, selection of variable speed drives, electronic overloads, and coming then into the next column, range of valves. So any valve that is typically used in the process industry is covered here. Below that, steam tables, which are much more specialised. And then the section below that, which is referred to as cross-functional, you'll find a lot of these objects are actually embedded in the other three groups that I've just been through. Things like the interlocks, the permissives, the mode, the alarm. You'll find some of those are already embedded in the other objects, but they can be used in their own right in a standalone fashion as well. Below that, you will see that there's a group of diagnostic objects. So these are objects that allow us to monitor how the system is performing. So looking at the CPU loading, looking at redundant controllers, monitoring the task performance, so we can get a first-hand look at how the system is performing, once again from the HMI screen. You'll notice that the first few groups of objects that I went through all started with the P underscore, so P for process. That last lot there start with L, so L for Logix. And then the next group, top of the next column, referred to as Premier Integration. So these are objects that relate to Encompass partner products, Endress and Hauser instrumentation, as well as some analog heart information out of the cards. And then below that, we've got a long list of time and date instructions, and not surprisingly, they start with a T. And then finally, over on the right-hand side, we've got some 64-bit math instructions to round out the library. So it's quite an extensive library. The functionality that is available in the library, we're pretty confident covers any process scenario that is typically found. Let me just get rid of all those squiggles. So I mentioned the documentation. So as part of the library download, as part of the Plant PAX system, there's a reference manual. You can see here. So the reference manual for the library of process objects, and what that contains is a summary of each of the objects in the library. As you can see there, there's a capture of a advanced analog input object. It gives you a brief description of what the library object does, gives you a link down the bottom here to the detailed reference manual for that object, and then shows you the add-on instruction and the HMI objects for that particular object. So this reference manual is a really useful manual. It's the first place to go to when you're trying to understand which object you should be using, or to find where the detailed manual is for that particular object. And there's another one there, a dual sensor analog input. And as I said, every object in the library is referenced in this manual. In addition, the manual also covers the use of the tools, which I'll show you later on. The library is all pre-configured with modes and security, and you can see there's a that's pretty much a capture from one of the help files on the library, where it talks about the different modes that the objects have, and the state model, if you like, moving from one mode to the next. And also similarly with security, which I don't have an image there, but there's an A4 size table showing the security configuration for all of the objects, and the recommended user configuration to make use of that security in the system. So what comes in the box? Well, I've already mentioned some of this information, but instructions on how to put the system together in the form of a selection guide. So when we're designing our system up front, we would make use of this selection guide, and that enables us to correctly size the system, to correctly specify the right processor and the right network architecture to make the system. And then once we come to the implementation stage, we also have a reference guide, and that has more detailed information around the design of the system. So recommendations on how to structure the code in the controller, how to set up the various tasks, programs, routines to achieve the best possible performance. And the final piece that we have in terms of assisting us in design of the system is the Process System Estimator in Integrated Architecture Builder. So this is a tool that allows us, at the point where we have an I/O count, allows us to determine the performance of the system, and allows us to select the correct processor, the correct I/O arrangement, the correct network, the FactoryTalk View configuration and environment, to make sure that the system is going to meet the performance criteria that is required. So there we see the selection guide, the reference manual, and the Process System Estimator in Integrated Architecture Builder. That's one of the wizards. If that's something you're not familiar with and you would like to become more familiar with, then certainly that's something that I can help you with outside of this presentation. More than happy to come and meet with you and work through the use of IAB and the Process System Estimator. So what else comes in the box? Well, we've talked about the library, and the View project. So within the library there's a template project for FactoryTalk View. So you don't need to start from scratch. There's a template project that has some screens set up, navigation system set up, has an alarm banner, has the security configured. So it really gives you a head start in getting the system up and running. And the tools. So we've got tools that allows us to automatically generate alarms, to use a spreadsheet, use Excel to do some configuration of the system, tools that really speed up the implementation of the project. So in terms of what version of the software we support, so you can see there that the PlantPX system, we're currently on version 3.1. And for version 3.1, you can use anything from Logix version 18 forwards and anything from FactoryTalk View 7 forward. The green highlights there are the versions that have been used to actually test the system in the lab. But any of the other versions there where you see the Y indicating yes, it's compatible, you can make use of any of those other versions. You'll see that there are earlier releases of the process library as well, back as far as version 1.1 on this chart. And you'll notice that there are some compatibility constraints to be considered on version 21 and 23. And that's just to do with signing of the AOIs. And the signature may need to be removed if you're running those earlier versions in version 21, 23 of Logix. Now, importantly, I mentioned the process system estimator in Integrated Architecture Builder, and I mentioned the manuals that allows us to select and size the system. And the way we achieve that, this is all around, as the image suggests there, preventing an accident, preventing having a system where when you come to the point of commissioning or implementation, you find that it just doesn't perform the way it should. Now this is achieved. Rockwell have a test facility in the US where they have many controllers and networks, servers, different architectures, where they constantly go through and run different process scenarios. And the outputs of that lab test are built in to the information that's in the manuals and also built into the process system estimator in IAB. And this is what we call a characterized system. So if we follow the rules that are outlined in the manuals, we follow the output that we get from using the process system estimator, then we're implementing a characterized system. We know what the performance is going to be. The performance is guaranteed. We're going to meet the key requirements. And that's one of the key things of PlantPAX. Standard Logix hardware, standard FactoryTalk View environment, using the process library, and this characterization of the system performance. That's what gives us a PlantPAX system. So how did it come about? Well, roughly over the last 15 years, Rockwell's been working in the process space. And one of the events, or one of the functions that Rockwell have annually, is something called the Process Solution Users Group, generally in conjunction with Automation Fair in the US. And that enables Rockwell to get feedback and get input from many users of the Rockwell system, many users of PlantPAX, and that feedback is then acted upon, and the features that are required, the features that are considered key, have been implemented in the system. So what we have now with version 3 of the system has been extensively used and developed in conjunction with end users around the world. It's not a system that Rockwell has developed and pushed out to the industry, but it's something that has been developed in close partnership with the end users. So you can think of it as a flat pack. It's a Logix and FactoryTalk View project that's ready to be bolted together build the system that you need to build. And you'll see here on this screen, this view over here is a view of one of the template projects that come with the library. So you can see there that we've got a menu banner across the top where we can manage our screen navigation. We're actually looking at the alarm screen that's already built into the system. There's some screens and navigation buttons built in to up the top here to allow us to get to some diagnostic screens. Down the bottom is where we manage our user login and security, and then there's the basic alarm banner down the bottom here as well. So that's ready to go out of the box as part of the library. And then we've already talked about the add-on instructions that come with the library and the various objects that we use on the screen. So importantly, it's been thoroughly tested, it is extremely well documented, and it's ready to bolt together, ready to go. So how do we actually put it together? Well, first step, we start with Logix 5000. Now, you can start with a Logix 5000 project that is in the library that already has the AOIs loaded. Out of the 100 plus objects that are in the library, any typical project is only going to use maybe half a dozen, 8, 10, 12 of those objects. So if you start with a project that's got all of the AOIs loaded, then you're using up processor resources with things that aren't going to be used. So the other option is to take a project that already has the task structure that we can see here configured in it. So a project in the library that has the task structure but doesn't have the add-on instructions loaded yet. So there's a couple of options of template projects in the library. In that scenario, what we do then is we import the AOIs that we need for our project. So typically that might be a DOL motor, a VSD motor, a couple of different types of valves, a PID loop, maybe some analog inputs. We bring in the ones that we need into our controller program. As I mentioned, it's already organised in terms of the tasks. It's just a matter of selecting the AOIs that we need to use. Now, similarly, in the FactoryTalk View environment, I mentioned that there's a project that is already configured as the banner, has the navigation, the security. If we start from that, it's simply a case then of using the objects from the library and placing them on the screen, creating the screen that represents the process that we're controlling. As you can see there, a typical example on the screen in front of you. So as I said, the major displays are already created. The login and user rights are already built, ready to go. Now, one of the really nice features of the Plant PAX library is that it's a single tag. It's a one tag link between these objects on the screen and the code in the controller. We link one tag, and that's all we have to do. So it's really, really quick and easy to implement these library objects. Once we've done that, we can run the tools. And some of the tools, the one that we're showing there is the Alarm Builder, and we'll show you that before we finish today, how the Alarm Builder works. And the Alarm Builder can literally save you hours and hours of work. Using the Alarm Builder, we can build hundreds, even thousands of alarms in a matter of minutes rather than in the many hours it would take to do that manually. There's also an online configuration tool that allows us to populate the configuration of the objects. Now, I mentioned that we can do the configuration from the screen, which we can, and which is great for making little changes, or if you've only got a small number of objects. But if we've got a larger project where we've got hundreds of objects, although we can do it from the screen, it's probably more efficient for us to do it with this online configuration tool. That's an Excel-based tool which allows us to, via RS links, connect to the controller and to configure the objects. By that we mean we can specify which alarms are enabled, which alarms are disabled. We can specify the alarm descriptions, the alarm delay times. We can configure a valve as to whether it has open and closed feedback or not. Pretty much everything that that is typically configured on these objects we can do via this spreadsheet. A lot of that information will already be held in spreadsheets these days. We use spreadsheets a lot in engineering on our projects, so chances are we've already got a spreadsheet with all of our valve tag names and descriptions and alarms, and we can just take that information and use this online configuration tool to push all that information down to the controller. Another use for that tool is at the end of commissioning, is to do an upload of the configuration into the spreadsheet, and that gives us a record of how the plant has been left at commissioning, which we can then use at a later date to compare to the current plant if there are any issues. The final one that we can see here is a colour change tool. So the library is configured around the current best practice in HMI, which is a grayscale approach. You may know it as ISA 101 or a abnormal situation management implementation. They both are working to the same end result, a HMI screen that has just attracts the operator to the areas that need attention. So we have very little colour on the screen unless there's an alarm action or something that the operator needs to respond to. Now that doesn't always suit for people. Sites have their own standards that are in existence and they need to comply with, and so using this colour change tool gives us the ability to work through the library and change the colours of the object. So rather than an object being grey, we can make that object red when it's running, green when it's running, whatever the standard is for the site. So it can be adapted to any site standard using the colour change tool. So this is a look at the faceplates and just showing some of the configuration that can be achieved from the screen. So the faceplate on the left there is looking at an interlock faceplate, and from here we can configure the normal state, the OK state. Is it a 0 or a 1 when it's in its OK state? Are we allowed to bypass that particular interlock? And if that interlock trips, do we need to issue a reset command before we can continue? So we can do that configuration here from the screen. The next faceplate is looking at a VSD. In this case, it's a VSD on an agitator, and you can see here that we're configuring the input scaling on the VSD, and we've actually got a number of tabs here that we can go through and do all of the configuration associated with the VSD from the screen here. So things like scaling, interlocks, labels are all configured here from the HMI. And as we mentioned, we can also access all of those things via the online configuration tool shown down the bottom there. So how does Plant PAX stack up or compare to a traditional way of integrating a system? You'll see here we've got some numbers down the bottom there, some percentages of saving. Now obviously those numbers depend on where you're starting from, what your starting point is, what you're comparing it to. And some people already have developed well-developed standards, well-developed code libraries, and so the savings in those scenarios may be a little different to the numbers shown here, but these are some typical numbers that we've found in our experience in working with people that can be achieved over a traditional way of implementing a system when using the Plant PAX approach. So in terms of controller code, if you haven't got a well-defined library, then each project is unique. Start from scratch. Different people will approach it in different ways. You know, if one engineer does it today and the next engineer does it in 6 months' time on the next project, you may find that things are done differently. With the Plant PAX Logix approach, where everything is pre-written, we find that you get a consistent standard and a faster delivery. Similarly with the visualization, same story there, that if you haven't got well-defined standards, each engineer will do it a little bit differently. It will take longer, and you end up with systems that are more difficult to maintain because each one is that little bit different to the other. In terms of the integration, this is one area where we can see big savings because of the way that the Plant PX bolts together or fits together in that modular approach. Very well documented, pre-tested, pre-configured, proven performance. Really good potential savings here on the integration piece using Plant PX. And then once the system is up and running on the operation of the plant, potentially less downtime. Problems are typically easier to find and rectify in a Plant PX system. The diagnostics that are available via the faceplates are typically far more extensive than what you would find on a non-Plant PX system. Most people just don't have the engineering budget, the time to develop the level of diagnostics that are available on the Plant PX library. The tens of thousands of hours that Rockwell have put into developing these over the last 10 to 15 years, most people just don't have that luxury of being able to do that. Some of the things that you can see here on these faceplates, if we look here at this loop control here, you can see that there's some different coloured bands here showing us where the alarm points are, showing us where the high and low value have been for the process variable over the last period of time. We can see when we're approaching trip points. We can see exactly what's happening on the system, and those features and functions really help us in keeping the plant running and in finding and rectifying problems when they do occur. And I'll show you some of those things when I go to the demo shortly. Here's another example of this. So if we start with the faceplate on the left, we've got a faceplate for a motor, and it shows us here this red symbol here with the eye in it. That shows us there's an interlock trip on that motor preventing us from running. If we click on that red symbol there, it launches this next faceplate, and this next faceplate shows us that the reason the interlock is tripped is because we've got this temperatures input is not satisfied. If we click on the temperatures input, it takes us to the next faceplate, and it shows us here that it's this housing temperature that's tripped. If we click on the housing temperature, it then takes us directly to this faceplate here and shows us that it's actually motor Z1 temperature that is tripped. So we haven't had to go to the code, we haven't had to refer to any manuals, we've just been able to do all of that from the screen and identify exactly what has prevented us from running that motor. So in summary, what is it? It's a vendor developed and supported standard that you can take and use for your system. It'll give you improved efficiencies, both in engineering and in the runtime environment with the extensive built-in diagnostics. It's a system that is typically simpler to integrate and maintain than a homegrown process control system with your own internal standards. And it ensures a consistent and uniform approach across all of your packages. Doesn't matter which engineer is designing or delivering, it gives us the foundation for everything to be consistent and uniform across the plant. So I'm just going to go now and leave the PowerPoint and bring up the live demonstration and just show you some of the features that we've been talking about. So just bear with me while I just change over here. Okay, so what we're looking at here is a view of a screen, just a typical screen that I've created representing a process plant. And you can see here we've just got a vessel, we've got a pump, we've got an agitator, number of valves, One of the things that you can see here is we've got this valve here just to the left of the vessel that's flashing red, and hopefully that's coming through okay on your screens. That's telling us that there's an alarm active on that valve. The text, hopefully you can see next to the solenoid symbol, is saying that the valve's closing. So the valve's trying to close, but it hasn't yet got a closed feedback. And so that's brought up a transit alarm saying that the valve has taken too long to transition. Down the bottom of the screen here, we've got an alarm banner, but you'll notice that there's no alarms in there at this point in time. That's because I haven't yet configured the alarms for the system, and I'm going to show you the Alarm Builder tool and how that can quickly generate the alarms and bring them into the FactoryTalk Viewer environment. So at this point in time, I've configured the system, I've built it, I've been through my basic pre-commissioning, I've proven all my I/O, I've gone through and I've enabled the alarms that I want to use, and then I can turn to my Alarm Builder tool to generate the alarms. Now the way this tool works is that we associate it with a logic controller, which I've already done here. So this reference here, AA_PAX, is the name of my Logix controller. You'll see here up in the top left-hand corner where it says RS Logix 5000 AA_PAX. That is the name of my program. So I've linked the Alarm Builder tool to that Logix program, and then I've also associated it with my HMI application. Right, so that's a couple of little setup things that take a few minutes to do. Just because of the time that we've got here, I've already done that for you. So yeah, it really does only take 2 or 3 minutes. It takes the Logix 5000 file, converts it to an XML format, and brings it into this Alarm Builder tool. Once I've done those two configuration things, I simply come down here to where I've got my alarm server configured, and I build my FactoryTalk alarm import file. I use the quick build option, and it comes up with this long list of things that's telling me all the things that it's going to do, how it's going to build the file, the naming convention it's going to use. And after you've done this 1 or 2 times, it's one of those pop-ups that you don't even read, you just click the yes button. So I say yes, it prompts me now for a file name, and just go into my project, locate where I'm going to build it. The file already exists because I've done this before, so I'm going to select the same file, and it then comes up and asks me, do I want to append new information to that file, or do I want to overwrite that file? So I'm just going to say don't append, overwrite. And that's it, it's done. It's created the file. If I now go to my studio environment and go to my alarm and event setup, right click here and I can import. And I'm going to import an XML file. I browse to the same location, select the file I've just created, and I've got an option here to update existing messages, delete existing messages, and in this case I haven't got any alarms, so it's not really going to matter which one I select. But it just goes through there and import has completed, and what that has done in my scenario has created 30 alarms. So it's created those 30 alarms in my system. If I go back to my client now, you can see here I've now got an alarm message in the alarm banner down the bottom here, which relates to this valve. It tells me that my CIP system inlet valve has a transit stall. One of the really nice features of the Alarm Builder tool is it puts an action on each alarm. If I now double click that alarm, it launches the faceplate for the object that has caused that alarm to happen. So now I've got some more detailed information. I can see that my valve is trying to close. I've got a transit stall condition, and I can use the features of this to take corrective action, rectify the problem as required. If I determined that the limit switch in the field was faulty and I needed this valve to operate so that I could keep the process running, I can come in here and just say, well, it no longer has a limit switch. Operate the valve without a limit switch. And you can see as soon as I did that, the fault's gone away, the valve is closed, and I can operate the plant. Now this is a feature that would not be available to the operator. The operator would see all of this tab as greyed out. Because I'm logged in as an engineer, I have access to that. But you can see the functionality that's built into the faceplate and how that can work for us. There's a help file, so I've just launched the help pop-up there, which explains all of the symbols and how the faceplate operates. Just before we run out of time, one of the other things I wanted to show you here was the interlock. So here I've launched my agitator, and I can't operate the agitator because I've got this interlock condition active. Now just to show you, if I click on that, it takes me to the source of that interlock fault, and it's telling me that because I haven't got any level in my tank, the tank level is less than 5%, I can't operate that agitator. Now, there's a couple of things we can do here. Obviously, we can put more product in the tank until it's above that 5%. But say that we determine that it's actually a faulty transducer on the tank at the moment. If I click on that yellow tank level less than 5%, it takes me to the analog input, the source of this level. If I determine that my field instrument is faulty, and that's why I can't operate the valve, operate the agitator, I can go into this maintenance mode, and this allows me to use a substitute value, and I can say, well, I know my field device is faulty, so that I can run my agitator. I know that I've got 50% tank level in there and I need to agitate that product. I can use this substitute value of 50%. You can see straight away my tank level now is satisfied. My agitator interlock is green, and if I was to put it into operator mode, I can now operate that agitator. So that just gives you a brief introduction into the power and the capability of the library and the faceplates in terms of troubleshooting and fault finding on the system. So that concludes what I had to say and what I wanted to show you. I will open up the microphones, and if anyone has any questions, then feel free to ask them now. Does anyone have any questions around that?
I'd like to say.
Okay, so just Felice Cuttajar here. I'm the OEM Business Development Manager for NHP. I'd like to thank you for joining this Machine Builders Technology Update. So in the context of the presentation that was done today, Andrew and I discussed whether we would cut the presentation down to be more focused on machine builders or have the full-on presentation, and I think the full presentation actually does show the power and potential of the plant PX solution. Just wanted to reiterate that it is scalable and is just as much at home on a small system, single vessel and single analog control requirement as it is on a large-scale plant. So if you do have an analog component in your control system, then you can use the Plant PX library to satisfy that need. So this presentation has been recorded and will be available on the OEM website, which is located on the NHP corporate website under business type. So that'll be up in about a week. So if you want to have a look at that, please do. So once again, thank you for joining us, and if you have any questions, either type them in or ask us now, or you can contact Andrew Allen or Chris Mears via your local NHP rep.
All right. Well, I think we'll leave it there, guys. So thanks for your attendance and enjoy the rest of your day.
A la fuerza, de salud, después voy, me paro al lado de la cara y la cara.